All right, folks, it's Bass Action back in action here. We're going to finish off the back of this foldable. We're going to do that second column. We're going to look at the remaining triangle inequality theorems. Now, on this right-hand side, we're finishing off this side here. On this right-hand side, the first one we're going to look at is the exterior angle inequality theorem. So the first thing that we want to remember is that in a triangle, if I create an exterior angle, remember that happens by extending a side, the measure of the exterior angle is equal to the sum of the two remote interior angles. So the way we wrote that before was that we would say that the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. So what the exterior angle inequality theorem says is that the measure of the exterior angle is going to be more than either of the remote interior angles, okay? So the measure of angle 1 will be more than angle A, and the measure of angle 1 will be more than angle B. And that should make sense to us because if it takes both A and B to create angle 1, then angle 1 all on its own should be bigger than either of them by themselves. Now, the way this is going to get applied is when we look, for example, here at example 4. Okay, if it wants you to, it'll give you, let's say, a group of angles, and it wants you to determine which of these would be the biggest, always understanding that pictures may not be drawn to scale. So, of these three angles, what we would want to do is we would want to identify which one of these angles would be an exterior angle. So we've got 2, 4, and 6. So here's 2, here's 4, and 6. I can see that 4 and 6 are definitely inside this triangle, and 2 is outside. So angle 2 is the exterior angle, and since angle 2 is the exterior angle, angle 2 has to be the bigger angle, because 2 is the exterior angle for 4 and 6. Now, sometimes the pictures do get a little bit harder, so let's look at our next group. We've got 11, 12, and 15. So let's go find those in the picture, 11, 12, and 15. And again, I can see 15 is an exterior angle for these two remote interior angles. So since 15 is the exterior angle, it is going to be the larger of the three angles. One more time, we've got angles 9, 10, and 11. Let's go find those in the picture. I've got 9, 10, and 11. Now this one is definitely more complicated because 10 I can see is an exterior angle, but it's not an exterior for these two angles that we would have expected. So we're going to kind of mentally zoom out, and we're going to think about this bigger triangle right here. Okay, so I'm thinking I've got this exterior angle, and 9 would be a remote interior angle, and then 11 is actually even only part of the remote interior angle. So this one's even easier to see. So 10 is going to be the largest angle there. And again, we just started by determining whether or not that one was an exterior angle. Now, this particular theorem does not get used a lot, but the most important theorem in this video is the triangle inequality theorem. And this theorem is going to get used a lot. We're going to use this one over and over. Now, if you struggle with this particular theorem when we go through these examples, please let me know when you come to class, because we do have a couple activities that we can do in class, some hands-on activities to help you understand a little bit more how this one works and why this particular theorem is important. Now, the way the triangle inequality theorem works is it says that the sum of any two sides, that should be a plural there, I keep forgetting to fix that in my file, that the sum of any two sides in a triangle must be greater. Now, it is important that we emphasize the word greater and not just equal to. It must be greater than the measure of a third side. So the first two ways that this is going to be utilized is we're going to give you some sets of sides, and you should figure out whether or not these three sides could actually make a triangle. Now, our theorem says that the sum of any two should be greater. So no matter which pair I pick, 31 and 16 compared to 15, 16 and 15 compared to 31, or 31 and 15 compared to 16. Okay, we technically would need to check all of those possibilities, comparing all the variations of the sum of two sides and compared to the third. But you'll notice here that I've got this little quick test, okay? And this is how we're going to check it in a faster way. The fastest way to check it is just simply to compare the sum of the two smallest, okay? Because if it works for the two smallest, it's going to work for any other pair. The sum of the two smallest will be greater than the third side. So now let's use that instead of having to go through all of them. When we look at our three sides, the two smallest sides are the 15 and the 16. So we're going to add those up, and we're going to say 16 plus 15 equals 31. Now, 31 equals 31, so this would be no triangle. Okay. Now, if you're kind of wondering at home, what you could do is, if you imagine taking a segment length that's 15, another segment that's 16, and another segment that's 31. If you tried to turn that into a triangle, what you would end up with would just be two segments that are the same length. There would be no space in the middle to make the polygon. Now, on the next one, again, we're going to find our two smallest sides, and in this case, our two smallest sides are the 3.9 and the 2.7, or 12.7. So I'm going to add those together, 3.9 plus 12.7, and I can see that is going to equal 16.6, and 16.6, when I compare that to the 15.2, does make a triangle. So this would be a yes. Now, the last one that we're going to do is we're going to look at, what if I only give you two sides and you have to find the third? The third one then has a range of possibilities. So we want to find, what are all the possibilities for that third side if I know that two of them are 18 and 7. Now, the shortcut for this one, and again, I have an activity that we can do if you need a little bit more on this. The shortcut for this one, to find the lower boundary, we're going to take the difference between our two numbers. So we're going to say 18 minus 7. And to find the upper boundary, we're going to add the two numbers, 18 plus 7. Okay, that's going to give us a lower boundary of 11 and an upper boundary of 25. And when we write that, we're going to say that our x, our third side, needs to be less than 25 and has to be more than 11. Now, it is important that you use the right notation here. You do not want to use an equals. You don't want to use this greater than or equal, no equality here. And you don't want to change this number to, let's say, 12, because we can get very, very close to 11, okay? I just can get really, really, really close to 11, just can't include 11 exactly, and I can get really, really close to 25, but not exactly. So on the last one, we're going to do, again, the lower boundary we're going to subtract, and the upper boundary we're going to add. So this one, our x value needs to be less than 144, and it needs to be more than 38. Okay. Those are all of our triangle inequalities, and in class we'll show how we can apply those and do some even more advanced questions related to them.